Hello, Cardstack community. This is Chris C., the founding director of the Cardstack Project, talking to you today about the card protocol. This is the fun part. This is the part that unites the ecosystem and provide an economic system to organize both the people who are buyers and sellers and the governors and the people who want to participate in this network that hopefully will become the tokenized software as a service way so that people can get the software they need to do what they need to do at a good price. So the card protocol, since the very beginning, we have capitalized CARD in whenever we talk about the protocol in terms of the token economics, in terms of the protocol system, the kind of economy, is because it really stands for 4 words, which is customer acceptance and revenue distribution. So the card protocol has 2 basic components. One component is the CA part of the CARD, which is customer acceptance. And that means that we want to have a network where people who participate in our ecosystem welcomes and serves mutual customer without payment or billing friction. So once you're part of this network, you accept card, you accept the Cardstack ecosystem's built-in mechanism for coordinating customer memberships and obviously payment and billing, then you can open your doors. This is not unlike saying that I accept Visa card or I accept the membership from anybody who is part of my airline mileage program. Once you accept this card or this customer that is mutual, you get a very seamless experience for your users. And in return of that, you're not doing this because you're kind of being generous, is because you expect to get a distribution of the revenue. And that's the RD part of the CARD, which is receive the correct portion of the overall revenue and share the risks or rewards. Rewards and risk are inherent in any type of business. And if you pool together and you say, hey, we all serve this customer together, then you get paid when someone is using your, redeeming miles in your airline or using your lounges or taking classes in your yoga studio because you're part of this network. And you want to make sure that when you go and open your doors to the people who hold this membership card or has this payment method or honor this coupon or prepaid card, that you will actually are part of this network where you will get paid for those services you're doing. So between customer acceptance and revenue distribution, those 2 components come together. And we'll talk a little bit about how this all works together in terms of the technology aspects of it, which is going to be the focus. And then the implication of the UI will kind of touch on some of the tools that we're giving users and also service provider to be able to manage and grok what's going on in this network. So let's jump right in. So the basic idea of the card protocol, and this is not the only type of thing you can make with a card protocol, but let's just assume a prepaid card. That's the simplest thing we can think of, which is I deposit an amount of value into a prepaid card, and then I can use that prepaid card, this little logo here, the Cardstack logo, wherever Cardstack is accepted. Let's take a look at what's going on here. So a prepaid card has an address, so this is like a credit card number. It has an original value. When you buy a prepaid card from a drugstore or from a retailer, from a corner store, whatever it might be, you give them $100 or $50 or $25. And in this case, we accept prepaid card that's generated by a thing that is not USD based because you can't give a $100 bill USD to the smart contract on the network. So you have to pay in some sort of token. So there was paid in there. And what you can do is you can now spend the balance on this prepaid card. And what we do here is this little symbol here is what we call SSC, which was called software and service credit or coupon. But we have really evolved beyond thinking the card protocol not just about paying for software, hosting, and whatever it might be. It can be pay for anything that is accepted in this network. So we basically are saying, let's take the idea of the SSC and rename it called spend supply. So this is basically you saying you spend $25.91 of USD so far. So this little symbol here means 1 cent USD. So it's measured, not pegged. It's measured in a US dollar cent as the kind of accumulation of how much you've spent so far. What's available now is what's remaining. So for $100, that's what's left. And that number is not entirely add up to 100. So people who do some mathematics is because a lot of what the card protocol is doing is managing the exchange rate or the risk of the fluctuation of the underlying currency. So if I pay in Ether and Ether goes up and down in prices, what I have to spend, what's left, may differ. So if Ether half in value, then maybe what is available now is half of 64, maybe 32. If Ether double in value, maybe I get a little bit more, maybe $90 left. So it really depends on what asset that's being paid to create a prepaid card. We remember that, we figure out when it was, what is it now, and then adjust what the available now balance is. Now, this is a little bit different than prepaid card or gift card you buy in a store, because they typically are pegged to the currency of the country that card is issued in, whether it's USD or British pound or euro it might be. But with a prepaid card that's based on a token ecosystem, it's very important for us to both make it easy for people to understand what's going on, but also provide that capability to be fair. So let's go a little more detail on the who is actually going on here. So the customer is buying this prepaid card, depositing the value and getting original value, and spending it and figuring out what's left based on calculation of what the market value of the underlying asset that generated its prepaid card. And then the service provider, anybody who's willing to accept card and provide a service, they will say, okay, you have $64 left, you can go and store this large video on my server, or use my protocol, my network, my smart contract network, and pay gas fees or whatever it might be. And when they do it, they would deduct from the balance by adding to this spent item. But the reason why we use US dollar as the way we express it is not because we're necessarily pegging to USD as for the value of the card. We're just doing the accounting in US dollar. That's for ease of reasoning. People roughly know what a USD is worth in terms of storage, instead of smart contract fees. A lot of crypto explorer end up converting everything US dollar for that purpose. And this idea that multiple servers, whether that's traditional app charging you $5 a month for subscription, a dApp that's charging you a fee when you do something, or an API to say for every 1,000 API calls, it's going to be 10 cents or $1 or 50 cents, whatever it might be. They can then say, oh, when you have this prepaid card and we establish an agreement, I'll just deduct from it. So this prepaid card is not just like a gift card for a electronic store that you can only spend on it. It's more like a Visa gift card where anybody who accepts Visa will accept that. And that's a little bit broader network than just saying, hey, I have purchased this particular credit for this airline. It's more like something that has fungibility across the alliance network, closer to Visa than a credit card point. So and my sense here is that the ability for people to accept this just means that they are willing to and have implemented protocol to deduct this balance in a standard way. And so what's nice about making a prepaid card, and this specifically related prepaid card, is that like a non-refundable Visa gift card, you can buy them in person. You can say, I would like to buy a $50 gift card, and someone will sell to you in the same places they sell lottery tickets or water or something like that. So we have this concept of retailer where someone can have these prepaid cards available at different denomination, like topping off a game card. They can give you one, and then you can activate it and add it to your account. So prepaid cards are the simplest concept within the card ecosystem, but we'll introduce later in the talk some other things you can do. So that's the basic idea. Customer buys a prepaid card. The service provider who accepts the card protocol will be able to deduct and use that as a way, and not having to set up a new subscription or get credit card involved in it. The prepaid card is a store balance that will facilitate the providing of service on the Cardstack network. So this acceptance network is a very powerful idea, right? Because at the end of the day, what credit card has really done is build 5 or 6 networks. I mean, Visa and MasterCard in the West, and American Express in the US and beyond. And then in China, you've got Alipay and WeChat Pay. And these are all acceptance networks. And what we want to be able to do is customers hold different types of currency. And sometimes it's fiat. Most people have either credit card or they even have cash. And then that can be converted to cryptocurrency. But the idea here is a prepaid card is pegged to any currency that we can measure in a smart contract in a protocol network. So obviously, card token is the native measurement and accounting unit within the card protocol. But if you put in USD, and ETH will then measure how much is that worth in that kind of exchange rate, both at the time of the creation of the card, the time as a performance service, and obviously for the merchant or for the service provider, the time where they withdraw it. And we essentially share the risk. It depends on when that happens. We do the right thing, so that if the currency went up tremendously, whether that's British pound or a Bitcoin or wrap Bitcoin, if we do it in a smart contract network, we will try to make sure that whoever holds the token or holds the pegged value of the token at that particular time benefits or protects from the fluctuation. So this idea of retained spendable value is that because these tokens that are backed by a prepaid card can be redeemed by the merchant, you know that as a service provider, I can look at this available now as that, okay, I know that there is this number of underlying asset, whether it's crypto or fiat will be represented by a stable coin, and that I can safely provide a service and know that the smart contract, the network, the calculation engine will give me the proportion when I say I want to withdraw this. And this idea of the 1 cent increment is divisible, so you can actually bill less than 1 cent, so the decimal points are as many decimals as we need, but as a way, as a unit of actions. If you look at what goes on in hosting services, cloud services, they typically no more than 1 cent. And that just allows us to make it more user-friendly and not have to have giant number like what Gwei or Wei is, to do something that is kind of human scale. Roughly 1 cent for API calls per 1,000 as a way to grok what's going on. So a lot of what we're trying to do is to lift the standards of understanding away from the low-level crypto protocol and even payment system and say, hey, all you have to do is understand this card, this idea of this physical card, look at it. And by the way, this prepaid card is rendered using the card SDK. So it's synthesizing data from on-chain data, from the smart contract, from exchange rates, caching it, aggregating user history. So we'll get more into detail about how that works using Cardstack as a framework and a hub and a development toolkit to draw the UI. But this is not just looking at Web3 and looking at a dApp. This is actually a synthesis of many information, but in a way that's easy to use to understand. So acceptance network is what we're trying to build using this prepaid card as the first type of card you can issue in this network. So let's go a little more deeper on what the overall schematic of our system is. So we were looking at customer just now, and we're looking at service provider. What we added on is 4 other concepts. So we've talked about the retailer, someone who's going to sell you the card, someone who is going to sell you the prepaid balance. We'll talk about the token pool or the value pool, where all the cards, all the Ether, USD, coin, Backcoin, and obviously card token that's pulled together exists on a smart contract that you can look at and say, hey, how much is in this network across all these cards that's being issued? And then we're going to account the usage, which is how many times have someone redeemed 10 cents, 15 cents, what kind of service is provided, not only from one service provider, but from all of them. And this idea of tally workers, because we're not just saying there's 3 of these and I give you 2 of that, a lot of it requires conversion rates, aggregation, calculating proportions, and stuff like that. There has to be quite a bit of analytics performed on the data that's available between the customer's data, the usage accounting, the token pool retailer, to determine what everybody's getting. So the tally work is informing not only what's on the prepaid card, but when a service provider say, hey, I would like to withdraw the money every month, and so that I can diversify it or use to pay my employees and stuff like that, the tally worker is the accountant, the bookkeeper that tells you, okay, you can redeem this much because you've charged people that much money, and based on the exchange rate, this is how much you can redeem right now. So let's talk about that in a little more detail. Customer used the prepaid card to pay the service provider. So that's the first relationship. And to do that, the customer is basically either directly or indirectly staking or putting or depositing a certain amount of value or assets into the token pool, which is based on smart contracts. And if the customers do not have cryptocurrency, which 99.99% of the humanity does not possess directly or even indirectly through exchanges and stuff like that, any type of token, that we want to leverage existing retail network. Could be e-commerce, could be in person, to sell, right, these prepaid cards. And then if you give a prepaid card, the staking will have been done by retailer. We'll go into that in a more second. So the retailer can sell these prepaid cards and then give people access to this underlying network without necessarily having the customer directly dealing with tokens themselves. And finally, the tally worker mark the prepaid card, the value, the spend history to the market so that everybody knows how much something is worth, how much they can deposit, how much that deposit is worth, and how much can be withdrawn. So use, pay, stake, sell, meter, and mark. So the usage accounting is part of the network, and that's done both partially on-chain and off-chain. We'll get into more on that detail. So the next part of this discussion gets pretty detailed into the mechanics of the protocol, who's doing what to whom between these 6 players. If you want to skip a little ahead, we can just take a look at what the UI is. But if you're interested in the design that we've spent a lot of time thinking about, not just researching things like state channel and side chains and scalability and stuff like that, and those are all important, but a lot of times when people think of protocol, they focus too much on the technical aspect of how to implement a step in the protocol and not really thinking about the interaction between players and people and what they care about and what they want to do and what the risk and reward for performing the action. So what we're going to focus on right now is the kind of the workflow between the different parties and why that has net when you look at the whole network, the effects we want. So let's start with what cryptocurrency people understand as kind of like a token ecosystem. The simplest way to use a token is to essentially interact with a smart contract. So in this case, we have 2 different types of smart contract on-chain idea. The token pool and the accounting are both on-chain. Right? It could be layer 1, layer 2, but they are essentially blockchain type of technology. The other people, the retailer, the customer, the teleworker, and service provider, is basically running UI or APIs or system and services in the cloud. And we have designed the Cardstack Hub so that the Cardstack Hub contains all the code and modules and functionality for the customer, teleworker, service provider, and card retailer to do the work. Okay, so most of what we're talking about here, 4/6 or 2/3 of it, is running in Cardstack Hub. And that's why we spend so much time designing the backend Cardstack Hub so that it can interact with a fairly narrow set of capability that we're going to put on chain and still achieve the prepaid card and other type of derivation of that. Okay, the simplest thing a customer can do is to use the UI, and we provide in Folio a UI for you to transfer a token, and then you deposit a token and say, hey, I would like to pay you $10, and then you transfer that from one account to the other account to a service provider. And that deposit, and this is something that we have been building, and it was the way we conducted the token event, is that when the deposit reached the smart contract, or in the card token, we automatically trigger the provision of service, where that could be granting access to dashboards, creating new entries in databases, or unlocking a domain name for you to start using under your name. So the service provider runs Cardstack Hub, listens to all the changes in the smart contract, in this case, the ERC20 contract card token, and provision a deposit service. So this is very, very simple. It is about integration of UI and API tier running in Cardstack Hub, using the smart contract as a message bus, as a way to translate this message, and as a proof that something has happened, and using that to govern access control, on-off switches, in some cases more sophisticated, taking smart contract things and generating new profile pages or generating new off-chain transactions. So that's what we have been building so far. What we're adding on top of that capability is this idea of a token pool. And a token pool is to say that you are, as a customer, dealing with sometimes not only one service provider. Your catalog of cards may touch many service providers, some of them providing API to give you exchange rate, some of them doing storage, some of them doing video conversion, and some of them are doing it in an on-chain and a cloud, on-chain way, and some of them are doing it in a cloud. So there could be many, many things you're using. So the way we do it is that, much like when people deal with a kind of multi-signature contract, they just like, let's pull our funds together into a group account. And that's what the reward pool is. So we're building this additional smart contract called a reward pool that allows customers to deposit and withdraw the token in this shared way. In America, we tip waiters and waitresses, and sometimes they pull their funds together and put the tips inside a jar. And that's what the reward pool, and at the end of the night, after the end of the shift, they determine, based on some accounting, usage accounting, what portion of this tip jar or this reward pool that we've done. That's the basic idea. It's a way to not having to do the transaction on kind of actual, making changes and giving coins and providing things. It's just pulled together and we delay the settlement. So that's the first idea of the reward pool. And what we need to do to know how much that's worth, assuming that the token is not just one token will fluctuate, but multiple tokens. If you have ETH and you have Bitcoin and you have card token, you have 0x and stuff like that inside this reward pool, it's going to be very hard to know how much is it worth. So we take the on-chain transaction history and you send it to the tally worker. So these are people who are monitoring Tally Worker is actually a piece of software. You can imagine them acting like an accountant and say, hey, what's all the transactions going on? Plus, because it is running Cardstack Hub, it can then access services that provides exchange rate on a given day or given time and know what the current market of the pool would be. And that allows us to know a little bit more information instead of just the token balance in smart contract, what the network is worth. So once you know what the network is worth, we can start measuring things and sending things out to users and telling them about how much they have and what they spend in a grokkable denomination, such as USD. So what we do is that when you deposit a token in a reward pool, we generate this idea of a prepaid card, which is backed by something called a SSC account, a spend supply coupon account, which is how much money have you spent and how much can you spend after that. And that's the creation of a ledger in a usage accounting, which would then track your spending history. So you haven't spent anything yet. Imagine in the old days, it would be a punch card. You bought 20 of something, and every single time you punch one of them. So this is creating the blank card so that you haven't spent anything, but you now have a thing that you can go and account for usage. Next step is that now we now know what the current value of the underlying tokens is, because now the prepaid card, which is the SSC account, is created, and now I can, per user, not just overall at the pool, I can tell each user in the prepaid card how much is used, especially if some usage is already done. And if you haven't used anything and you staked a currency that's fluctuating, then it will already be marked to market. So that will the available now will go up and down with the underlying asset that's creating the prepaid card. Now, for people who do not have a token to deposit, you can buy a prepaid card, not buy the token. You can buy the usage, the prepaid card, which allows you to use the network from a retailer. So net, the customer goes to retailer, the retailer get here's $100 card. So you can buy this prepaid usage coupon with, let's say, a minimum of $5 USD. What happens afterwards is what the people in the Ethereum space or broader ecosystem call decentralized finance. We're trying to do some finance-looking thing, but in a way that is not specific to a particular ecosystem. This can be done in any type of backend or service that they use. So retailer receive either in cash or through a credit card API $5 from a customer. So now I need to get that $5 into the token pool. And what they do is that they can buy USD PEC coins. So based on whatever the currency the user is bringing in, they will buy a PEC coin from either a centralized or decentralized exchange. And then on behalf of the user, on behalf of the customer, deposit and lock the PEC coin in what we call a reserve pool. A reserve pool is another part of the token smart contract that locks up this thing and say, hey, this has been deposited. And because we do measurement and movement in card token, card token is the native measurement thing. Think about that as the membership reward points of American Express or ultimate reward points of Chase or whatever. It is the number one point, and then you have like transfer between your hotel points or your airline points. But in our network, the Cardstack network, card token, it's in the reward pool. So we need to take the reserve pool and see how much the value has been put in there, and using the exchange rate provided by Tally Worker to then calculate how much card token to put in. Now, there's a set of card tokens already in the reserve pool. We're trying to keep the value balance. So you put something in, you take something out, and you put in the reward pool. Now the reward pool is now funded with the token that would be as if the customer have card token, either through the TGE or since thereafter, but instead, they're going through a retailer to do that operation for them. So all this kind of purple stuff that's going on here is what we call the clutch mechanism. So the idea is that someone is doing it for you, and unlike other token that you put in yourself, you can't really withdraw it. You've kind of put it into this pool for the service provider to redeem, or when they perform the service. It's one-time, non-transferable purchase. You purchased it, but any person or any party in this network would know that, the reward pool now grew by $5, which allows them to perform up to $5 of service. Now, this obviously also allows us to calculate bonuses and base. So it's like, if you buy some points today in this airline, you get a bonus 20%. We can do that to incentivize people to make deposit, to use the thing. And that's one of the nice things about having the COTS token as a native token, is that we can incentivize the type of customer behavior, service provider behavior, retailer behavior, so that they makes sense for them to use this network to begin forming this acceptance network, and knowing that the earlier they participate, the more value they're going to get by essentially earning bonuses for doing right things. And credit card do that. 1,000 points of sign-up balance when the card first launch, and then later on becomes 25,000 because they've got the users, they've got the network effects going, and they will reduce the bonus. And we're going to, follow a similar launch strategy for point systems. Okay, so now we have reward pool for both customer who deposit token directly or through a retailer. And the next step here is for the service provider to start looking at this reward pool and say, hey, I want to serve your customer because they have value in this pool, and if I provide the service, I will get some part of it. The first thing they need to do is to sign up. So they have to make sure that they are taking some risk. So they're staking some amount of card token, which is the native governance token of the system, and say, hey, I'm going to deposit $1,000 so I can bill up to $1,000. So if there's some weird shenanigans going on, we can slash this stake and to either refund the customer or replenish the reward pool for the good performers, the people doing it correctly. So the service provider create an account or create an entry within a smart contract that they can now perform the service by staking some amount of token that protects them. Now, obviously, the ratio of how much stake you need to perform how much service or to bill how much or withdraw how much can be adjusted on-chain and evolve as the smart contract get more smart. But that's the basic idea. You have something at stake before you start serving customers. So if you're providing really bad services or you're trying to just bill people, then there is some ways for us to pull that back and say, hey, you're doing the wrong thing. Let me slash your stake. But generally speaking, you put stake in, you're now part of this database or part of this ledger, and then people can start working with you. So when a customer says, I would like to start using this web host who accept card as my hosting service, they will have to go to a teleworker and say, I would like to create a payment authorization from a chosen service provider. So this is kind of like saying, hey, how much value in USD term can I send to or give the service provider the ability to deduct against? So the teleworker is saying, based on the market value and maybe based on the volatility of the underlying asset, I believe you can spend $64.13. Now, if the asset is very volatile, the authorization could be less than that. It could be maybe $40. So telework could use a formula, whether it uses simple statistics or machine learning in the future. It could be just using CPU and database, which is what the current generation of Tally is using. But it could also use GPU as a way to accelerate certain types of detection to say how much, given that we know everything that's going in the network, we know the exchange rate, how much will I authorize? And that authorization becomes a billable usage up to the available amount. And that authorization is handed to a service provider, not on chain. Just like, hey, I'm coming here, I got a little slip that say I can go spend this much. Okay, good, you can go and do the thing. The service provider can then accept that authorization to enable billing, and that's what the service provider use, that kind of balance and the provable usage data using off-chain calculation, but cryptographic in origin, to then say, hey, here's usage. They did $5. They pick up this thing. They bought this thing. They play with this game in the thing, and then that spending history accumulates for the service provider. So that's how the customer spends. And then when it's done, that usage and building data continue to go to the tally worker, which then allows us to deduct the actual value, what's been used up. So the spent, the 2591 keep going up as the service is accumulating, and the available balance go down and down and down. And that allows us to update UI and also prevent you from authorizing payment authorization that is, try to pay 6 people $64. You can only get one authorization, and that deducts the tally worker uses as the underlying data. So this is now, as you can see, pretty close to how credit card systems work, this kind of authorizations and stuff like that. And because for delay settlement, which allows us to do microtransaction, especially with long-term billing relationships, which is what we want to facilitate, you need all these things. And then the last step is when the service provider wants to withdraw, they go to teleworker and say, hey, look at not only what the customer is spending, but all the customer, 1,000, 10,000, 1 million customers going on, each with different prepaid cards and balances. how much can I withdraw? And a similar thing, the tally worker can say, hey, you can withdraw up to this withdrawal limit based on how it's done. And then you can forward the initialization to the accounting system, which allows you to see how much SSC you have. And then through a sidechain mainnet protocol, you can then redeem the card token and actually get it transferred to your particular wallet in your addresses. So the idea here is that most of what's going on this diagram, and it's color-coded with different color, is the green is the mark-to-market, using the tally worker to figure out what's going on. The purple is the clutch mechanism, the ability for someone to get you into the token ecosystem without having to hold token or even have a wallet, but you get a prepaid card that you can use. And then the orange is the payment authorization workflow, and then the yellow is essentially the withdrawal workflow. So I'll pause for a second. This is a lot to take in, and certainly this is our overall plan for the network, and we're gonna take incremental step, starting from a smart contract and the tally, and work out to especially the authorization and the machine learning to determine risk at the overall network. But one of the nice things to note here is that Cardstack is basically running all the complicated stuff. What's going on in token pool, like depositing token and creating an account, these are pretty basic smart contract stuff. Most of the really interesting layers are actually implemented using our functional reactive properties in Cardstack Hub. And that's one of the reasons we felt like we need to do a lot of work in making sure the Cardstack Hub can do these processing logic. And more importantly, all these API calls, or like requesting authorization, purchasing, and forwarding things, are all protocol done in the web way. It's protocol that's done in the middleware in the API. They influence, using cryptographical primitive, what goes on chain and sometimes get validated on chain before it gets distributed. But a lot of the protocol is actually what we call cloud protocol. And that's totally fine. Like PayPal is 100% a cloud protocol, or even Stripe doing credit card payment is all, you can look at it as a protocol, but it's all done in the cloud. So that's the idea here, is a mix of on-chain, off-chain to create that user experience and illusion. We never forget that the prepaid card is in the middle, and that's what we're trying to do. Now, obviously, with this type of infrastructure, we can probably do quite a bit more on using the card protocol. So you can have a game card, a card that's denominated in an in-game currency that's not pegged to anything. It's just something you can use, and that makes it so that you don't really need to market because it's just the native currency. So you can use the card protocol just as usage billing and as a way to use the underlying SSC as a ways to measure these things on that. There's a lot of conversations about users want to use new users want to use dApps and they don't have any Ether, so they can't pay gas. So a dApp can provide a gas card, almost like, here's a fleet card for you to fill up your gas if you're doing delivery for a company. This allows the user to be subsidized to have certain, like if I have 50,000 Gwei to use over time. Now, one of the nice things about these ideas is that you're not giving the person Ether. These are non-transferable. They can only be used through meta transaction and other type of funding mechanism where we are only going to pay people who are providing transaction and putting things on mainnet or something like that. You can't just like, hey, let me get some gas card from and sign up for a 100 account and accumulate some nice number of ETH. So this is a non-transferable spend for transaction only gas card. It could be implemented in different ways with meta transaction relayer, and we also working something called transactional refueling, which basically means that we deposit in an address that it's multi-sig control before it goes out there, or a smart contract. So this could be someone can sell your gas card as a way to use credit card to start doing Ether stuff, or it could be a gift as part of a free trial. Now, obviously, the free trial can be denominated in something that is in the local token. So this would be similar in concept to what companies and entities and protocols trying to do. It's like, how could people try out your service without having tokens? So this would be another non-transferable way of doing it. So they can like trade it and sell it. They can only use it to redeem services. A happiness token, every day you put one token and they'd say you something nice, and then you get happier, right? So this is about this idea of signing up and then getting this balance that is non-transferable using the clutch mechanism. It can only be spent with service provider. It cannot be extracted, withdrawn in a more traditional token way. So this could be a good way to make sure that people, again, don't pull these tokens together for financial gain, but actually try out the service and use and learn what happiness token or happiness network means. Now, on the other hand, when a customer or worker, someone who is working in your network, is doing something very valuable, facilitating the usage, facilitating the network, they should be given reward. And this reward are something that's earned with action. So it's what we call quantifiable work. So this is something, it's like, you did some work, thank you. This is, extra bonus. And that can be actually something that can be redeemed directly in the network. So you can use these earned rewards, almost like credit card rewards to earn more flights or more things. But it can also be transferred out because it is something that is almost like proof of useful work. It is something that people actually have done real work to deserve. And it's not just a vehicle for moving numbers around. It's something that you can say, hey, here's an invoice, what I've done for the network, and I got $13.19 worth of value from that. And then I think one of the nice things about the subscription is that as users start having ongoing relationship with the service provider, it makes sense for them to switch to, instead of a pay-as-you-go and microtransaction way, to say, it's worth $5 a month, and I'm going to go ahead and do that and be a charter member of this network. And that just means that the deposit that goes into the reward pool is ongoing. So each user is putting $5 a month automatically, either through a credit card transaction, repeating that subscription with a retailer, or it could be a allowance to a smart contract for that to happen. I really think that subscription is what we're trying to do, and that moves up the value chain. But prepaid card help us understand the basic operating principle of what the card ecosystem is. Subscription card is just another type of card. It has similar types of affordances and account. It just automates certain process, so you don't have to do it every month, and you don't have to top it off, for example. So you can even prepay this stuff. This idea is that all these things are value in, whether it's gifted or earned or purchased by the different participant in our network. The UI for this stuff is just you double click on a card, you see what's going on, almost like opening up a wallet in your smartphone. Very easy to do. And the Card SDK, which is our front-end technology in the way we create the schema and the model and templates for these things, we've always accounted for these kind of identity and payment and membership card to be an integral part of how we unlock the value of this software and service network. Because you can make content card that reflect blog and podcast and data card that has invoices and asset card. If people are just using your app for free, and you have to find out how to bill them for it. Maybe charge them a transaction fee, hold their wallet, or put ads on them. And those are the reason why it's hard to make the web a real ecosystem, because each website you're using are not really serving you, they're serving the advertisers or other people. By having reward card, subscription cards, and prepaid card at the core using the same SDK, then we can find a way to say, hey, you've earned $13.19 and you can use that to pay for a subscription. The subscription is $5 a month. And by the way, you still have a $64.30 balance you buy. And then you use that through a spendable balance to build the network for it. So we show posters at a higher level, an easier way to grok of what's going on. As you can see, this is a six-sided thing. So we talked about the reward pool. We talked about reserve, which locks tokens that are not card token, so that we know that, hey, it's backing the value of the services and contribute the reward pool through this automated balancing mechanism we're doing on-chain. And the render services is what the billable usage is. And then between billable usage and deposit, right, from the retailer and the retailer can be making deposit for the users or the user making themselves. The purchases, the actual new value coming in the network, the market rates tell everybody what the deposits and earnings are worth, and then eventually you withdraw, and that could be directly to a wallet or through the Card SDK and the integration of Cardstack Hub. You can have financial intermediary, where there's traditional ones or the crypto ones, provide services where things get deposited directly to your bank account, Venmo account, or whatever, even LibreCoin, if that's what people want to do. But the idea here is that during the interaction with the protocol, you are basically just like having a cloud subscription, everything is happening in the background, deducting against your balance, and only when you say, hey, I want to take the money out and put a deposit, do you interact with what we know as either banking or crypto or financial service organizations. So that's how Card SDK, which is how the UI and how the logic is, and the Card Protocol and Cardstack Hub in this case is doing a lot of the calculation and analysis, serving as the basic runtime for Tally, or basic runtime for running a retailer, or certainly basic runtime for the service provider who's providing all kinds of services, whether it's database or query services. So that's been our basic technical framework, and hopefully the Card Protocol, which sits in the middle, allowing users to use multiple types of services, help coordinate this multi-currency payment and billing network across multiple providers. So quite abstract. Hopefully that makes sense. We've been working very hard to not only build the protocol aspects of it, but also think about how this would actually end up using as a user. So in the previous talk, we talked a little bit about the product line, the product strategy of Cardstack. So we have this idea of a product grid. And it's not product lines per se, because these lines kind of overlap. When your product lines, like we do this for businesses, we do this for end users, we do this for developers. But in our network, they are all overlapping. So what we just discussed is the providers, who are service providers, want to know that they're staking and billing and then getting a reward, and then knowing that a third party, Tally, is telling us how much it's worth. The developers are building on the Card SDK and the Hub so that they can also get portion of the reward. So that's kind of what it overlaps with. What we want to drill in a little bit today as it relates to the protocol is two things, which is what does Tally look like? Because it's actually doing a lot of the work, and there's a lot of management levers. You have to stake, and you have to withdraw and create relationships and stuff like that. And also Folio, which is less low level, is more like what the user would see. A Folio will be similar to the iOS wallet app. You can say, this is my mileage card, this is my credit card, this is my prepaid card, this is my Apple card. And we have a similar concept. So Tally and Folio, one is for the provider mostly, more low level detail, more on the accounting system, and Folio is more of a how much money do I have, how much can I spend, and what membership do I suit. So let's take a look at the two things, and these are work in progress. We hope to launch the beta very soon, but let's take a look at some of the work that we're doing on the template and how it looks, and also because of the way Card SDK works, when we're building a template, we're also building the API. So the same thing that powers the user, the same logic, the same computation is actually also serving data to the Oracle so that the on-chain data get the same approach. So in Tally, we have two concepts. One concept is this prepaid card, because we need to mark the card, the value on the underlying asset to the market. And the other one is the service provider. So someone who is billing and accumulating usage across different user base and charging different users different prepaid card, and they will have a page and can summarize what they're going and doing. So in this prepaid card here, we show something that is probably takes a little bit of thinking. This prepaid card is funded using the Aragon token, so ANT. It could be funded using USDC, using DAI, using ETH, but in this case, we just say, hey, let's use an ERC20 as a deposit, which means that the available balance has to be some continuous calculation of this stuff. And we create something called SSID. This is kind of your account number, which is a hash of a bunch of stuff, and the subscriber address is who is holding this prepaid card, and be able to do that. And the usage, as you can imagine, is accumulated over time. These are how you have used this balance that you have staked and therefore have it on deposit in various types of service provider. The active service provider is how many service providers are you using this for. One for, green one is for hosting your photos. The purple one is for dealing with your accounting system, and then the light green one could be paying gas fee for you. And as you add the number of provider, your share and your pie chart of how much you're using this one unified prepaid card to pay 10 people, 20 people, and because of the way Cardstack works, one card can tap into 10 different services, and different cards can tap on a different crypto network. So this diversity of this pie chart may change, and you can use this as a way to subscribe to your provider. But if you take a look at what what the providers are doing for you, you see that you're using Cardspace, which is hosting a website for you, so you can have an on-ramp, and then Hubs are us. So it's a service that is providing Cardstack Hub service and all the things that can be included in the plugins, and then you have actually billed $11.23 thus far. Then you can go ahead and see what the provider detail, and you can say, hey, I don't want to do subscription to you. I want to revoke your ability to bill against my account because you're overbilling me, and that's the way it's going to happen. So that's how the consumer or the user, the customers, can manage the relationship of who can bill against them. There's currently 3 active service providers. So from a service provider point of view, these are all the service providers who are listed or staked card token, and their stake determines some limit of how much they can bill against. And now they can kind of go inverse, pivot the other way from a data point of view. I have 23 subscribers, and I'm average billing this much per month. $15, and as much like cloud services that grow, that could be a big thing. And that's the idea here, is that the service provider manages the customer relationship from their angle, and Tally is like a neutral accounting administrative web dashboard for that to happen. So that's Tally. The capability of Tally and the UI on Tally is going to be launching soon, and this is actually acting as the oracle to the smart contract, so that the same data that users are seeing in a Tally node is the same data that's informing activity on chain. Now, this is, finance, so it's a little bit kind of complicated. Folio is a lot simpler. What we want to do is to say, hey, you have a prepaid card, you have a membership card, this is the current balance. You don't need to get into a lot of detail. So that's it. You have some assets in Ether and card, and it could be a wallet because you have MetaMask in this case. But in the future, we also support other type of wallet, coming from a Trezor, coming from even some of the custodial or non-custodial apps that use it. We just got to report to you what the value is. And we use the same mark-to-market and the market oracle to tell you what the USD value or whatever value that you've shown. Tally is something that's new, but Cardfolio, we shipped a beta, an alpha of that to show the basic capability. And Cardfolio Codebase, we shipped in open source in January, is actually powering both the Tally, which is more administrative and more complicated, as well as the new Cardfolio. So that's the 2 things that's launching soon. And once if you have a MetaMask account, you can start using Folio. And then for Tally, you can actually stake and become a service provider and start experimenting. Tally will initially launch on testnet because there's a token pool and stake pools involved in it. We want to make sure that those are working correctly. Cardfolio is basically a read-only app, like an Explorer, a wallet, and then it uses MetaMask for now as a transaction thing. So that's going to go on testnet, and you can use that and play with it soon. So this is an interesting description of the underlying smart contracts. We call it the smart contract necessary for the card protocol. As you can see, most of the heavy lifting is actually done in Cardstack Hub in off-chain land. So there are some part of the protocol that needs to happen. There's contracts and oracles and integration and creating that various level pool, whether it's the reward pool, the stake pool, or the reserve pool. So the basic idea here is that we are trying to keep the service area of smart contract as small as possible. Smart contracts are high capability because we have a Turing complete language in Ethereum, and we're building this mechanism in Ethereum for 2 reasons. One is that the tools are mature, and we're using the Open Sapling library, so it's upgradable. We can improve it over time. But more importantly, there's a lot of representation of assets, stable coins like DAI or USDC or True USD. There are capability for you to participate in money market. You can take loans against it if that's what you want to do. And for this idea of creating a deposit, it makes sense for us to leverage all these other decentralized finance or DeFi innovation, and it's essentially providing a pool, a multi-sig contract that allow those things to be converted and staked to create this much more dynamic and much more user-focused billing mechanism. So you can see here we have the reward pool, reserve pool, the oracle, which gets the thing, and then the active service registry, which is which customer, which service provider has a relationship, and that can be canceled from both sides. So if you look at the reserve pool and reward pool, they are essentially smart contract that locks these things together and provide capability. So the reserve pool is mostly about how much other token you're putting in. It's kind of a multi-sig wallet. Reward pool is denominated in a card token, and any reserve that is deposited will create the corresponding reward pool. The withdrawal and the payout comes from a reward pool. And then with integration, and we hope to integrate with a decentralized exchange like Uniswap and maybe even Kyber, you can automatically convert it back to what you have. And the reserve pool would be there to say, hey, this is the total network value that is in the system. So the card protocol has these relatively small pieces of modular code that in support all the things that's going on in smart contract, as well as the smart contract supporting the overall protocol that we've gone through. So, Cardfolio is the first user-facing launchpad that we're using to show what you can do with the Card UI, the Card SDK. Right now, we're doing prepaid card because there's a lot of moving pieces, and with prepaid cards, you get basically all the tally and the usage billing things right. And once you have that, then you can use the prepaid card to pay for registering Ethereum name services. You can buy crypto collectibles to the degree that makes sense. If it's unclutched, if it's clutched, then you can only pay the fees on them. Integrating with other DeFi or DAOs, and obviously with the identity and the credential, taking a look at what's going on both within the Ethereum space, but also beyond, like the Decentralized Identity Foundation that Microsoft is help sponsoring, and see if we reflect that stuff in a card way. And if it's a card and it's built on Card SDK, Cardfolio is like the standard UI for you to go visualize all this stuff. And we're going to do a talk a little bit later in the month to show you how that will all look and how you can have very different affordances and control and actions and be able to look at them. But the most important things about Cardfolio or the Card UI that underlies it is that you can wrap the power and then chain this together. Please take this and do that with it, and when it's done, go and send it to this person. So this kind of orchestration allows us to use this basic unit block and class as kind of almost like, songs in a playlist, and then your playlist could then decide how to orchestrate it together. So Cardfolio is for end users, and then Tally is administrative layer to coordinate what is the four-sided economy. As we mentioned, we want to do as much computation using the functional reactive properties of Cardstack Hub. So when you update one cell, almost like Excel, all the other formulas propagate through the sheets. That's technically possible in Ethereum, but each time you have to wait for block time, you have to pay gas, which is not always possible. But by doing this off-chain computation in Cardstack Hub, we can keep all these numbers up to date, and it's indexed, and it is accelerated through databases and Postgres and all these kind of JavaScript capability. And in the future, and very near future, we're going to be tapping into machine learning algorithms so that the calculation of risk can be done by looking at all this data that's available in the Tally kind of database and say, hey, do I believe it's $40 worth of risk or $60 worth of risk, and that can influence users. What we want to do is interact with the chain with technique that's proven. Like a lot of people are inventing many new stuff we keep track of. We just hosted a workshop here for state channels. We're looking at different types of capability. Right now, I think Oracle's is the easiest way to do it. But this is not centralized, right? Tally is running on top of Cardstack. Cardstack Hub can run anywhere. So you can have 50 different Tally nodes in different countries running the same algorithm, performing the same analysis on the same on-chain data, and then you can choose which one to be your payment or withdrawal authorizer, and they will have some risk. If I tell you that, you're withdrawing $40, and then you actually do not have $40 worth of value, then the Tally worker essentially have to take some slashing of the stake as well. So Tally will become kind of what we call analytic miners. They're providing the analysis service using the Cardstack functional reactive properties, and they participate and get chosen either dynamically, randomly, or through a long-term relationship to provide the service for the different participants in the network, acting as the accountant of this decentralized economy. So we are going to continue, as you can see, evolve what's on-chain, what's off-chain, what we call the on-off-chain mix. A lot of projects, especially in the Ethereum space, want to do as much possible on-chain as possible because that makes sense for when you're dealing with decentralized finance, where you really want to have a very accurate measurement on-chain on the asset underlying it. When you get into payment system and membership system, that gets more and more capable for us to use off-chain techniques and still use cryptographic primitive like SSL or HTTPS is not on-chain, but it's cryptographic to make sure that things are not drifting too much off of what's been staked on-chain. And the key here is that the reason we have to evolve the on- and off-chain mix is that real web apps, ones that serve users every day, millions, billions of users, needs to be easy to use, fast in terms of the UI, has to be cost-effective, It has a decent trust model. I think what we have right now with the super centralized digital superpower is leave a little bit of desire, and obviously secure, not in terms of theoretical security, but also people can't lose their funds and stuff like that. So this is pretty high bar, and I think blockchain and smart contracts and has a lot to offer if it's using if we're injecting blockchain in the right part of the ease, speed, cost, trust model, and security. And so one of the things we're researching is that currently our spend supply, the accounting ledger for usage, is done using Cardstack Hub. It would make sense for that to be done in a sidechain or plasma chain, so that different service provider knows, oh, they already billed $3 or $6 and stuff like that. They share that information in a more efficient way than going to a mainnet, which is good for putting larger amount, but not good for 20 cents when your gas fee of recording that transaction costs 20 cents of gas on a bad day. And so that's something that we are definitely spending a lot of time thinking about. What's nice about the card protocol is we can swap out the implementation to use a plasma chain. Let's say one became available without changing much of the other protocol. So we're going to continue looking at it, analyzing it. Think of Cardstack as the payoff, right? So Cardstack has all these working system and UI, and we can go ahead and say, oh, that's ready to go. It's plasma chains are working go. Let's switch over to that. And suddenly everybody is like, hey, we're using plasma chain underneath it. It's almost like going to a service. It's like, hey, we switched to Amazon Web Server to Azure or Google Cloud. The users who are booking a card don't really care. Idea here is that we're not really thinking that user would care whether we're using a plasma or sidechain underneath it. It's that between ease, speed, cost, trust model, and security, we've improved by switching to these kind of protocol when they're ready to go. And then one other aspects of it is we really want to improve on the end user experience. We like MetaMask in terms of giving people an understanding of what does it mean to be a direct participant in this ecosystem using MetaMask as their wallet. But for most use cases, for people who are buying a prepaid card, then to ask them to put MetaMask to hold the balance doesn't completely make sense. So we want to have a hosted, yes, non-custodial wallet, so that is both balancing security and easy to trust. And there's a lot of really nice research on threshold multisig and new product coming on the market base. We're keeping an eye on that space and seeing if we can turn that into an abstracted scheme. So card key would be you can sign your transaction 3 different ways: the traditional MetaMask way, using a Trezor wallet, and maybe using a future type of threshold multisig where you may just use an iPhone plus a hosted service to go and do the same thing. The goal of Cardstack has always been about bringing the decentralized protocol to the surface so people can understand it and grok them through the composableness of card UI. And signature and balances and prepaid card and relationship with service provider are just different aspects of these kind of units of relationship. And those can all be represented using card both on the front end, but also as a way to orchestrate the back end. So for us, Cardstack is at the center of this network, and we see the protocol as the economic layer to make it all worthwhile. So people are not just doing it because they believe in open source or they believe in decentralization, but because this is the best way for them to access the greatest number of customers, the greatest network of collaborators and other businesses that's working together so they can provide seamless service to mutual customers. And hopefully this logo of this little thing become as ubiquitous as the Visa and MasterCard logo as to say, oh, they're using Cardstack, they're accepting the card protocol, they can serve me now, and I'm going to get everything I need through a reasonable fee. And it's going to allow us to build the Web 3.0 that not only have the qualities of the connected web, but also decentralize the value part, decentralize what is now locked into app stores and other type of relationships, and obviously advertising supported things. So hopefully this talk gives you a better understanding of what we do in the protocol, and we'll be releasing the source code of the smart contract and the available thing. But more importantly, we'll let people play with it on testnet so that within the next month or so, we want to be able to get community feedback on how this is working. And obviously, the payment mechanism will evolve. But as we add more and more service, more cards, more communities, features, then it will become more and more obvious why this prepaid card becomes the path for all the things that you can do with the decentralized web. So thank you very much for your time today, and I'll give you guys an update when we're ready to do a demo. Thanks.